Okay, it's time for another screencast in research methods. This one we're going to look at a more complex kind of quasi-experimental design. This design is going to be one where you have one or more independent variables, which are not either any of them randomly assigned, where groups are not randomly assigned. And what is notable, different from a t-test in this design, is that you have more than two groups. So you can't use a t-test because t-test only compares two means. So let's look at some data. I believe you've seen these data before. This is what I call the teacher grading data X3. And we have, just to look quickly at our sample size, we have this is a meaningless report, but everybody has a descriptive ID. There are 288 cases, at least started into this data set. We recorded their gender, their age, their highest degree of education, whether or not they were full-time teachers, whether or not they were, I believe that's pursuing certification. Their ENV is our independent variable. And that was non-randomly assigned, but the teachers, pre-service teachers, whatever they were, came in and they were assigned to consider grading policies in one of three conditions. Either the children to whom they were supposed to reference in their grading decisions were tagged as, the teachers were told that they were low achieving, that they weren't told anything about their achievement level, no treatment, or told that they were high achieving. So rather than two groups to contrast, you have low, a placebo, and high. And we also know that some of the participants were in early childhood, some were adolescent, some were childhood, and so on. I believe that we are only going to consider, at least in one of these analyses, the early childhood, but we'll leave that for later. We managed them, we measured them on several characteristics there, which had to do with their grading decisions, etc. And for now, what we're going to be using as a dependent variable is their effort. Their effort is a measurement of whether they condoned awarding a portion of a student's grade based on whether or not they perceived the student made an effort. And again, the independent variable is this quasi-experimental manipulation where they were either told that the students to whom they were going to assign the grades, for whom they were going to assign the grades, were low achieving, high achieving, or they were told nothing about the students. So what kind of analysis can we do with this? Well, as I said, we can't do a t-test because we have three groups, not two. And a t-test is only for comparing two means. So what we have to do is an analysis of variance. Notice that in SPSS, what we call a one-way ANOVA, which is where you have one predictor, is under compare means. If you have already watched or in class paid attention to my little summary of the general linear model, you'll notice that also an one-way ANOVA can be performed, and we will perform it in a few minutes, under the general linear model, what's called univariate, which means you have one dependent variable. So for the time being, we're just going to use the compare means menu, and basically the most complex kind of analysis that's available under that menu is the one-way ANOVA. So how does the one-way ANOVA work? you put in your dependent variable. What are we trying to predict? We are trying to predict their intention to condone, how much they condone the inclusion of effort as part of a grade. And we are looking to compare that attitude among three groups, the groups that have been assigned to these different conditions. And so basically it's very simple to do this. We are going to ask for the descriptive. We are going to ask for the homogeneity variance test to see if we meet our assumptions. And so let me make sure that you can see this screen. So we look here at our outcomes. We see the descriptives. Note that the case allocation to the three groups is unequal. That we will say for the time being that that's because they were not randomly assigned in some way. Maybe they were intact groups, who knows? And they're different means. It's pretty noticeable that the mean on condoning effort is lowest for the high-performing group and highest for the low-performing group, meaning that pre-service teachers or whoever they are most likely to condone including effort in a grade when students are low achieving. By the way, don't draw any big conclusions from this because the data, as typical with these presentations of mine, are gummied up for the purposes of teaching. Rid of that circle. And if you look at the test of homogeneity of variances, then the homogeneity of variances values are all significant, and with assumptions, which homogeneity of variances is an assumption, you want the test of the assumptions to be supported, or you want to maintain the null hypothesis for an assumption. So you do not want the significance level to be below your alpha for a test of an assumption. The null hypothesis is that the assumption is met, and you do not want to violate assumptions. So, and then we will go down to the bottom and see our results. So the sum of squares divided by the degrees of freedom gives you the mean square. The F test is the ratio of the mean square to the error term, which is 71, and which is significant at the level of less than 0.01. Never write down that a significance level or a p-value is exactly 0. If you look carefully enough, there is some value after that, and it's best to say p is less than 0.01. So what is good here is that we know that there's a difference among these three groups. And look at the means and we can say, well, I'm just desperate to draw with these things. This mean here is definitely higher than this mean here. And it also is higher than this mean. So low is just highest. But we actually don't know if those are significant differences. And this is important in ANOVA. It's because you have more than 2 levels, you don't know which difference between means is the significance one. What you know with the omnibus test is that one of the differences among means is significant. But you don't know which one. If you have 2 groups, low and high, and there's a significant difference, then you know it's between low and high. But if you have 3 groups and there's a significant omnibus test, omnibus means somewhere in that there's a significant difference, but it doesn't tell you where. Yes, you have a difference between low and no treatment, but is it significant? Nah, I don't know. You have a difference between no treatment and high. Is it significant? Nah, I don't know. So what do we do about that? Well, we go back to our data and we have other tests we can run. And the other tests are called post hoc. What that means is that after you learn, I have a significant omnibus test, there's a difference somewhere. Then say you want to know, where is it? Well, we call these post hoc tests because they're not a priori. They are, you weren't really sure that there would be a difference somewhere, so you tested the hypothesis that there is. Now that you know that there is, or you believe that there is, you really don't know where it is. You did not have an a priori research hypothesis about the nature of the differences. Therefore, when you think about testing afterwards, you're really at the exploration phase. You could be kind of fishing. And so what we want to do here is we want to control for type 1 error. Now, I'm not going to get into the math of controlling for type 1 error, except to say that when you run a lot of post hoc tests, or a lot of tests, just plain a lot of statistical tests, even though each one you control for type 1 error at a rate of alpha of 0.05, if you run a whole lot of them, eventually you're going to make a type 1 error. So we have all these ways of controlling, which are called post hoc tests. We're not going to worry about the nature of them, but we are going to say, hey, if you want to know where this difference lies, you're going to run a post hoc test. And the one that we are going to choose, because it's kind of the most sensible one for this kind of analysis, Bonferroni would be sensible too. We're not going to worry about it too much. As you see, there are a lot of them. The world of post hocs is abundant. I don't know, it's full of stuff. I've known people who were big fans and in fact even invented different post hoc tests. So anyway, we're going to run the one called Tukey, which is very commonly used. And otherwise, note this is exactly the same analysis. It is the same. It's just we're going to look a little deeper. So we're going to get the same results. And we're going to go past the results that said the omnibus null hypothesis. Oh, you can't see this, I'm sorry. So we're going to get the same results, descriptive test of homogeneity of variance. We're going to go past where it says that the omnibus null hypothesis is rejected. We know that, and now we want to look at post hoc tests, which are called multiple comparisons. And this allows us to compare any one group to any other group. And what Tukey will do is it will tell you the mean difference between those two groups, and it will put a little asterisk if it's significant at the 0.05 level. And someday, if you want to, if you take Stats 2, probably from anybody, your instructor will teach you how to do that, how to run a Tukey on your own. But in the meantime, it's available in SPSS, and it tells you, for instance, because there are these asterisks, that means that the effort post-test score of pre-service teachers who were shown grading scenarios where students were low achieving were more likely to condone effort than those who were not told anything about the students. Low is stronger on effort than none. It's stronger on effort than high. It's, some of these are redundant. No treatment is stronger than high. That's a new one, but the rest of them are just replicants with the comparison in the other direction. So that's a post hoc test. Okay, now we're going to take a breath. What we've done is we've moved beyond in prior presentations, t-tests, to when you have more than two groups. We have 3 groups here, and we have compared the groups. We have found an omnibus difference somewhere among the 3 groups, and we've done post hocs to see that in fact every pairwise, we call them pairwise contrast between low and no treatment, between low and high, and between no treatment and high. All of those are statistically significant. Okay, but someone might say, hey, Bonner, that design wasn't even very good because you don't know how these people's inclinations were at pre-test. And they weren't randomly assigned, so we can't assume that because they were randomly assigned, they were all normally distributed in their differences at pretest. They could have had systematic differences. So we've measured pretest. Right there, we've got a measurement of pretest. How? Say we want to put it in to this equation. We want to say, understand and include in our analysis how much perceptions of the value of effort in a grade or inclusion of effort in a grade before they even thought about the type of student accounted for their perceptions about the type of, about grading in terms of effort at the end of this treatment. So how do I put that in? That's a continuous variable. Considering it like it's not something we experimentally manipulated. So what we're going to do is we're going to perform an analysis of covariance. An analysis of covariance is exactly intended to let you put in usually information prior to the experimental study that will help explain background differences in the participants. Now, this is not available under compare means. It is available under the general linear model. Pretty much anything in compare means can be done under the general linear model plus. So we're going to look at univariate, which means we're predicting one variable that is our dependent variable. We have one dependent variable, we said that, and we are predicting their perceptions about grading based on effort after this. We are using as our fixed factor, which we'll call our independent variable, their environment, the low achieving, high achieving, or no information group. And we have this box down here for covariate, and we're going to put in their pretest. Don't worry about random factors, and don't worry about basically anything else in here. So we're just going to run this analysis. But in this case, we are putting in as a covariate their pretest. So I will say okay, and then share the output screen with you. So we're running this with the same people as before. So you're going to see kind of the same, some of the same output. I didn't ask for descriptive statistics, and I didn't ask for any some tests of assumptions. But what we see here under the tests of between subjects, comparing the three groups, is that in fact, pretest of effort did matter. This isn't something we're particularly interested in research-wise. We pretty much assumed that pretest was going to matter. So we were putting it into control for variability due to background characteristics. And even after controlling for pre-existing differences in perceptions about effort, the category to which people were assigned is still significant with sig less than 0.01. Okay, let me say that again. In a test of perceptions of grading based on effort, after controlling for the amount of variance accounted for by preconceptions prior to treatment, then so ruling out or controlling for the amount of pre-existing differences, the manipulation was statistically significant, p is less than 0.01. The omnibus test was rejected, F so-and-so and so-and-so, and the hypothesis that there were no differences among groups was not upheld. So we're back to where we were before, which is which differences are significant. And you run post hocs on this again. The post hocs with the analysis of covariance look a little bit different because when you have a covariate, you have to do something called estimated marginal means, because you've kind of, well, you've adjusted all the means from simple means of effort at post-test for those three groups to the adjusted means after effort pre-test has been put in. So it's not a simple post hoc, it's estimated marginal means, and you just put it in there and it will ask you, do you want a statistical comparison of the effects? And you can put in one of these tests. In this case, I'd probably put in Bonferroni. I'm not going to worry about this very much. And in fact, I'm not even going to do it, but except to let you know the results are the same trend as before, which is that all the contrasts between low and no treatment, low and high, and no treatment and high, each one is statistically significant. Okay, so we're going to do one more thing. And this is kind of an extra that I think goes beyond what you cover this semester in your statistics class, but I think it's useful to at least have a glimpse of it. And this is the case where, let us say that we knew more than two things about these people. In this case, we know two things. We know which condition, well, we know three things. We know their score and the dependent variable, effort. We know their score about effort, perceptions about grading based on effort, before they were assigned to these three different stimuli. And we know the three stimuli to which they were assigned: low performing, no information, high performing. That's all that we're putting in as information into our statistical model. So let's say that we were interested also in whether these differences among participants were attributable not only to their perceptions about were the students low performing, high performing, or their general default perception, but also whether they differed according to the developmental level of students that they were working with. And we happen to have that variable. So let's take a look at it. So in the data, we have these three groups, early childhood, or actually we have a whole lot of groups. However, if we run the frequencies on this dev, we will see that, in fact, everyone is in one of those three groups. Don't ask me why, even though we have all those other categories, everyone in this is in one of those three categories. So what we can do is we can think about not just, does it matter in people's attitudes about grading, whether they are in thinking about low achieving students, thinking about no particular kind of students, or thinking about high achievements, but does it matter what age group they are training to work with, or whether they're working with special education students? That's kind of an interesting question. So to answer that, we are going to go into the general linear model, and we're going to look for univariate because we're still only trying to predict one dependent variable. But we have another fixed factor, and that is the developmental level of our students. I'm going to take out the covariate for this, just because the covariate will make the results a little bit messy. And I don't particularly want to deal with that for the sake of this presentation. So what we want to see is whether both the type of achievement level of students matter in teachers' perceptions, and also the area of certification they're studying. Let me make sure you've been able to see. I don't think you were able to see that. No, you weren't. I'm going to pop up this screen so that you can see it. This is under univariate. Our dependent variable is still post, and our fixed factors or independent variables are the experimental, quasi-experimental var-env, and the development, I call it dev, it's not really developmental, special education, childhood or adolescent. And looking at the output of that test, we see the numbers in each group, and then we see the between subjects effects, the condition of which they're thinking that students are at, the achievement level is statistically significant, and developmental level is not. Overall model accounts for 34% of variance in the independent variable, and that's R squared. So again, you might ask, as you did, so we don't have to pay attention anymore to developmental, and this is called the interaction between the two. That's kind of going a little bit deeper into factorial ANOVA than we're going to. This is called the interaction though, and it has to do once again with what that great paper by David Berliner, that it could be that people's perception of how they should do grading at different achievement levels is influenced by their grading level, their development or type of students they work with. However, because it's not statistically significant, it appears that that is not a factor. Those two factors, achievement level and the type of students, do not interact. And in fact, the type of students doesn't, as it were, matter regardless. So once again, we're not quite sure which are the differences. This is still a null hypothesis test. We don't know between which groups we have statistical significance. And rather than show you the same type of post hoc tests as before, I'm going to show you a different way, which can be done simultaneously, to look at this, and then we'll be done for now. Look at these between groups, and that's to get a plot. So it can be very nice to graphically look at the relationship among means. And so in this case, we want a separate line. How do we want it? Let's get, I never can decide how I want it. Let's get a separate line for each achievement level, and along the horizontal axis will be the development or the type of student. I should have renamed that. I really dislike that name. You make sure you can see this. Yeah, I think you can see that. And don't worry too much about how I set this up for these are called profile plots. And in terms of which I put on the horizontal axis and which I put as separate lines, in fact, you can get multiple plots with different ways of laying them out. And in fact, I often do that because because you can lay it out in ways that end up being confusing to read. You also can get a bar chart. I'm not going to do any of these things for this purpose, but I will show you that it can be elucidating to look at the plots. And so bringing up the output from here, we're going to see all the same things at first, but then we're going to see these plots. And what these tell you is the means for each of the levels at the different combinations, or types at the different combinations of achievement levels. So you can see that the overall line for high achieving students in terms of awarding part of grades based on effort is very low. Because the overall line across all of these development types, or whatever we want to call them, is low across the board, regardless of development type. It's called a main effect. Type doesn't matter. These are all low, and they're all considerably lower. They're all statistically significantly lower. You can't tell that from the graph, although you can kind of see the trend. But you can't tell the significance test without doing those post-hoc tests. But it's nice also to be able to see it. And in this case, you can see also with no particular instructions across the board, similar perception of the value of effort, and high perception of the value of effort across the board with low achieving groups. So the type of students that teachers worked with does not seem to influence their thoughts about grading based on effort very much, but the achievement level of the student does seem to matter, such that high achieving students are much less likely to have teachers who support grading based on effort. And that's really about it for analysis of variance. We did one-way analysis of variance, which is when you have more than 2 levels of a single independent variable. We did analysis of covariance, which is when, in this case, it was one-way analysis of covariance when we had one independent variable with more than 2 levels and a covariate. You can actually do that when you have one independent variable and only 2 groups, like a t-test, but you want to have a covariate. And then we did post-hoc tests on those. And then we did what's called a 2-way or factorial analysis of variance, where in this case we had 3 groups on one independent variable, the achievement level of the students who were the stimuli, and we had 3 groups on the second independent variable, the type of student that the teachers were being trained to work with. And we used that as a predictor, as predictors, and looked at the means for effort at the end of the treatment using profile plots. So those, I hope, will be useful kinds of analyses, and we're done for this session.